Hello everyone, this is INE Foundation Lab 3 and section 7.2 IPv6 OSPF version 3. Okay, let's review OSPF network types in the DMVPN phases, and I will come back and conclude this section. Okay, let's start with the DMVPN phase 1 and how OSPF network types work in the DMVPN phase 1. First network type is point-to-point. Because hub uses MGI interface, as we know in the DMVPN configuration, it cannot establish neighbor adjacencies with more than one spoke. Then this network type will not work with DMVPN phase 1. Point-to-point is not working in DMVPN phase 1 because hub uses MGI interface and it cannot establish neighbor adjacencies with more than one spoke. The second network type is broadcast in DMVPN phase 1. In broadcast network type, OSPF network type, it automatically establishes neighbor adjacency because there is no direct spot-to-spot connectivity between spot routers, and we just need to make sure that a spot router will never become DR or PDR. And for this reason, we have to configure spot with IP OSPF priority 0 on all our spot devices. If this IP OSPF priority 0 will make sure that a spot router will never become DR or BDR. Now broadcast. This is the same as broadcast, or this is MBMA. Same as broadcast. It automatically establishes neighbor adjacency, and there is no direct spot-to-spot connectivity between spokes. And we just to make sure that a spot router will never become DR or BDR. And because it's non-broadcast, we have to use neighbor command for each spoke on hub. This is the same as broadcast. On a spot router, we type IP priority 0, and on hub, we have to specify network and spoke IP addresses. And point to multi-point. It automatically establishes neighbor adjacency and type to hub. I will explain this a little more later. There is no redirection, no need because there is no redirection, no need to use IP priority 0 on spoke like broadcast and MBMA, and we don't have to use neighbor command for each spokes on hub. It's best option for the VPN phase 1. This is point to multi-point. And point to multiple number broadcast is same as point to multi-point. It's automatically established neighbor. There is no DRVDR, and we have to use this is the opposite of point to multi-point. Here we have to use neighbor command for each spoke on hub because it is non-broadcast. On hub we have this specified neighbor. This is only we have this specified neighbor for spawn hub. This is the VPN phase 1 OSPF network types. Broadcast, point-to-point is not working. And then we have broadcast and non-broadcast. Point-to-multipoint and point-to-multipoint non-broadcast. Phase 2, in the VPN phase 2, point-to-point is like the VPN phase 1 because hub uses multiple interfaces. It cannot establish label just with more than one spoke. Then this network type will not work in the interface either. Okay, broadcast. It's automatically established label. And we just to make sure that the spoke routers will never become DR or BDR, and each spoke router has the root for other spoke router. This is the difference between the phase 2 and phase 1. In phase 2 broadcast, each spoke router has the root for other spoke router, and there is direct spoke to spoke connectivity, and this is the best option for the DMVPN phase 2 broadcast that we talk. And on a spoke, we just to make sure that spoke will never become the RBDR. This is IPv6 priority by this command on spot rotate. On the tunnel interface, we specify IPv6 priority 0. On non-broadcast, the same as broadcast, plus we have to use spoke, we have to enable command for each spoke on hub. On hub, we have to specify neighbor. On a spoke, we have to specify IPv6 priority 0 to make sure that the spoke rotate will never become the RBDR. And point to multi-point in the event phase 2, the next hub IP for spot will be hub, and spot to spot traffic will be sent through the hub router, and there is no direct spoke to spoke connectivity in point to multi-point, and it's not a good option for the DMVPN phase 2 conversion because there is no direct spoke to spoke connectivity on point to multi-point. And point to multi-point broadcast. This is next hub IP. Next IP for the remote on spoke will be hub. On spoke will use hub IP address as the next hub. Next hub IP. And spoke to spoke connectivity is to the hub router, and there is no direct spoke to spoke connectivity. And we have to use neighbor command. This is not a good option either. The best option for the open phase 2 is broadcast. And in the open phase 3, point to point is not working for the DMVPN phase 3 either because hub uses multiple interfaces. And in the broadcast network type, each spot router has a route for other spot routers, and there is direct spot to spot connectivity, and we just to make sure that spot router will never become DR or BDR by this command, IPv6 priority 0 on the tunnel interface on the spokes. And non-broadcast, each spot router has the routes for other spot routers, and there is direct spoke to spoke connectivity. We just make sure that spot will never become DR or BDR, and we have to use spinnerback command on hub for each spoke on hub by this this one. This is one question. Point to multi-point. In the event of phase 3, the next hub IP address of routes for the other spot routers is hub IP address. And we will see the symbol to show, we will see the symbol in short route, which means that the next hub is overwritten by an HRP, and there is direct spot to connectivity, and next hub remains unchanged. And point to multi-point on broadcast, this is the same as point to multi-point. The next hub IP address of the routes for the other spoke router is the hub IP address, And we will see the symbol in Sharpie root, which means next hop is overwritten because of a Sharpie, and there is direct product connectivity. And because this is non-broadcast, we have to use neighbor for each spoken hop. Okay, for this scenario, this is important concept. DMVPN 1, 2, 3. This is OSPF network type and next hop behavior. In OSPF, the next hop shown in IPv4 routing table is always the neighbor that sent you the LSA. OSPF network types on the MGI tunnel determines whether OSPF will preserve the original advertising routing addresses as the next hop or override it to the hop. This is keep in mind. This is best practice for this type of scenario. Best practice for Cisco DMVPN is to use broadcast or non-broadcast disposal, so that OSPF next hop remains the advertising hotel parallel IP. This is best practice for Cisco DMVPN design. To use broadcast or non-broadcast, so that OSPF network type remains the advertising hotel parallel IP. In contrast, point to multiple network types forces the hop IP address next hop. This is our final best practice is always set the MGI tunnel to broadcast or embedment mode and force a spokes OSPF priority to 0 so that hop is there or be there. This ensures adjacency form cleanly and the OSPF network and the OSPF next hop is the advertising content IP, which is the best practice to use broadcast. Broadcast network type will make sure that next OSPF next hop remains unchanged. Okay, let's configure this section. Okay, configure router 1, 2, 3, and 7 with OSPF version 3 for IP version 6 in area 1, 2, 3, and 7. One, 1, 2, 3, and 7 with this 1, 2, 3, and 7. 1, 2, 3. This is we have to come for OSPF version 3, area 1, 2, 3, and 7. Okay, now RDL VPN for application configuration. Here our 7 is our hub and others are our spokes. Let's see, verify. This is our 7 is our hub router. DMVPN IPv6. This is our hub router activity. DMVPN IPv6. And 1, 2, 3 are our spoke routers. 7 hub, another spoke. Okay, let's configure OSPF and start with hub. We'll show run interface tunnel 200. The config interface tunnel, and I simply type OSPF version 3. Then this is our process ID. So after split them process ID, I will use 200 either. And I have to use IP version 6. I can't specify either IP version for either. This is I just this like MBGP. This is I just family for IP version 4 and IP version 6. Area 1, 2, 3, and 7. That's it. I have to conquer this command. Another unspoke there. Config T interface tunnel 200. Config T interface tunnel 200 and config T interface tunnel 200 either and specify network type. To show OSPF, show OSPF version 3 IP version 6 maybe. Okay, now as I can see the error, I have to specify my fix my OSPF network type. Let's verify. Okay, this is full. This is init state. My spokes are in init state, but my hub is in full state. Okay, let's continue. Okay, ensure that the next hop after routes exchanged in the DMVPN network are not changed. Okay, as I explained before here, our next hop we have in OSPF network top for the DMVPN. The best strategy is to use the broadcast network type so that OSPF next hop remains the operating content. Tunnel IP it will remain unchanged. Okay, next change our network type to broadcast. Let's see the current network type first. So OSPF version 3, IP version 6, interface tunnel 200, and current network type is point to point. Okay, let's change broadcast. And keep in mind this is because I am using network type broadcast. Let's verify. In phase 2. Then I have to use IPv6 0 on the spoke either. I have to specify this command on the spoke for broken spoke type for the MP phase 2. Okay, let's change property interface. Broadcast, and because this is spoke, OSPF version 3, 200, IP version 6, parity 0. Property interface tunnel 200, broadcast, and parity should be 0. Interface tunnel 200, parity 0, and broadcast network. And on hop, auto specify IP network task broadcast. Okay, now let's verify. OSPF IP version 6 maybe on this is pull on pull on DR other because it is hub and this is DR other we will see DR other on hub and on a spore. This is full DR and full DR. That's it. Now we have full OSPF connectivity without any issue. Okay, let's continue. Which is next suppose are not changed. It means we have using broadcast or MBMA. Let's go. Okay, another we have to redistribute in loop path 0 of our previous network of DMVPN routes into OSPF version 3 and ensure the we have full reachability to yeah, so ensure that it means the spore of the loop path without passing through half. Don't use any sort of shortcut. It means we don't use DMVPN pairs 3, we use DMVPN pairs 2 here in this scenario. Okay, let's verify. Best add beta are loop back 0. We don't use DMVPN pairs 3. To show down interface on 28. There is no operator shortcut on sport. And on half, there is no operator with redirect on half. It is DMA page 2. I can specify this. We use tunnel mode UI motor point. Either it means on the spark, it means this is DMA page 2. Okay, let's add betas or loop back. Okay, to add beta, but let me first create my root map. Root map and specify with name loop back, connect the loop back. OSPF version 3 IPv6 loop back. نتبقى on match interpeslupav zio can and specify and then go water to Sharon of section water OSPF then I have to go add this family IPv6 unicast then redistribute connected my specify module tab name this one. Okay, hold on. I'll go to this map. Hold on. Top section to OSPF and copy this section. This family I'll need it with this with now. Okay, let's want to go this on here and other with this one. And this one. First create my route map, then distribute it in my OSPF. Okay, do show IP version 6 with OSPF with OSPF. Yes. Okay, I can see where are the loopback 1, 2, and 7. This is via 100, 200. If I do show IP version 6 with OSPF. Okay, and then let's ping my loopbacks. No, it's not. Okay, let's start with this. Let's create this CLS and for each interface, I think this one. And I have connectivity. Okay, this is our assessment, this one. Copy and done. New connectivity for my loopbacks. Okay, that's it. I hope you have enjoyed this video and thank you for watching.